Okay, today we're going over 6.3, dividing polynomials. So let's say we want to divide the polynomial x squared plus 3x minus 12, and we're going to divide that by x minus 3. So this is a quadratic trinomial because the highest degree is a 2 and there are 3 terms, trinomial. So the first way we're going to learn is by long division. So we're going to set this up as x minus 3 as the divisor, and we're going to use long division to divide this. So the first step is to divide. So we're going to divide the first term divided by the first term. So we have an x squared divided by x. And when we have the same base, we keep the base and we subtract the exponents. If there's no exponent, then the exponent is a 1. So it's really x to the 2 minus 1, which is x to the first, or just x. So then we're going to put that up top to start our quotient. The next thing is we're going to multiply x times x minus 3. So we do x times x minus 3. We distribute that in, and we get an x squared minus 3x. After we do that, we're going to put that right underneath here and line it up for your like terms. X squared minus 3x. We put that in parentheses and subtract it. Make sure you put everything in parentheses so that you know to subtract this entire binomial. So we do x squared minus x squared will cancel. 3x minus a negative 3x is the same as 3x plus 3x, which is a 6x. We bring down the negative 12, and then we repeat this process. So the next thing is to divide. 6x, the first term, divided by the first term. 6x divided by x. Your x's will cancel out, and you get a 6. Next step is to multiply. So we go 6 times x minus 3, we distribute in our x, and we get a 6x minus 18. We put that underneath here in parentheses, and we subtract that whole thing. 6x minus 18. We subtract 6x minus 6x is a 0, it cancels. Negative 12 minus negative 18 is the same as negative 12 plus 18, or 18 minus 12, which is a 6. So therefore, this quadratic divided by this linear binomial is x plus 6 with a remainder of 6. Therefore, we now know that both of these are not factors of this quadratic, because the only time they are going to be factors is when you get a remainder of 0. So therefore, this is not a factor. Let's try another one where we're going to use synthetic division. So the other way we're going to learn is using synthetic division. So this is by synthetic division. So you can only use synthetic division if you have x plus a number or x minus a number as your divisor, which is the denominator or what you're dividing by. So let's say we're going to divide, and we have x plus 1, and we want to divide 3x cubed minus 4x squared plus 2x minus 1. So in order to use synthetic division, in the long run, if we know what we are dividing and if it's going to be a factor, then we can say if this is a factor, then I know that x equals negative 1 will be the x-intercept. For example, if I have an x squared plus 6x plus 8. I know that's factored to be saying what multiplies to 8 and adds up to 6, x plus 4, and x plus 2. So if I wanted to find what the intercepts are, I would set this whole thing equal to 0, and I would solve for x. So therefore, this would give me x equals -4, and this would give me x equals -2. So these are both my x-intercepts for this quadratic. So if you look here, if I am dividing by x plus 4 and I get that to be a factor, meaning the remainder is 0, then that means that x equals -4 is going to be my x-intercept. So it's the opposite sign. So when we're trying to divide this one here, we're trying to check to see if x equals -1 is an x-intercept. So what you're going to do is you're going to reverse the sign of the divisor. So we're going to reverse the sign here. So since it's an x plus 1, we're going to use -1 to test it. So I just drop this down, reversing the sign. Now I'm going to rewrite all of my coefficients. The coefficients are the numbers in front of the variables. 3, -4, 2, and -1. If there's a variable missing, then you have to put a 0 in its place. For example, if there's no 0x squared, I'd put a 0 here instead. Okay, now that this is set up, the first thing is to bring down your 3. So you bring down the first coefficient. Next, you're going to multiply -1 times 3. Multiply. -1 times 3 is a -3. And you're going to put that right underneath your next coefficient. The next step is to add these. -4 plus a -3 is a -7. And then we're going to just repeat this process until we get to the remainder. So we multiply. -1 times -7 is a 7. We add, we get a 9. We multiply. We get a -9. And then we add, and we get a -10. So therefore, this is not a factor of this cubic polynomial of 4 terms, but we do know from here what these numbers are. So once you come up with these numbers, here's what it's giving you. This last number is always the remainder. So we know that the only time that this is going to be an intercept is when we get a remainder of 0. So it's not an intercept because our remainder is -10. The next number is always your constant term, meaning there's no variable with that. Your next number is always your linear term, meaning you have an x with that. And then your next term is your quadratic. Your quadratic term always has x squared with it. So when I divided this cubic by this linear, I got this whole thing, which we can write it all together as a 3x squared minus 7x plus 9 with a remainder of -10. All from here. Okay, so this leads us to the last thing, which is the remainder theorem. And the remainder theorem is still using synthetic division. So the remainder theorem is going to say we want to find p of -4, and this is using the remainder theorem. So the remainder theorem is saying that we're going to use synthetic division using p of -4 to evaluate p of x equals x to the 4th minus 5x squared plus 4x plus 12. So we're going to use the same thing here, and when it's p of a number, you're going to use this little number, this number in the parentheses in the box. So we're going to use -4 here, whatever that number is here. And then we have to look to see if we're missing any terms. So we bring down our coefficients. This is a 1. Since there's no x cubed, we have to write it in as a 0x cubed. So we have to put the 0 next. Our next number is a -5, a 4, and a 12. So we do the same process of synthetic division. We bring down the 1, we multiply and get a -4. We add 0 plus -4 is -4. We repeat, -4 times -4 is 16. We add, that will give us an 11. We keep repeating, -4 times 11 is -44. We add, and we get a -40. We multiply, we get a 160. And then finally we add and get a 172. So the remainder theorem is saying that your last number is always your remainder. So therefore, p of -4 is equal to 172. So therefore, this is not an x-intercept, but this is giving us a point. So the point here is, or the ordered pair, is -4, 172. And that's where this quartic will pass through -4, 172. It's giving you a point. And the remainder theorem is telling you whatever the last number is, that's what p of -4 is equal to. The other way you could have solved it is if you plug in -4 in for x here, you'll get the same number, which is 172.